Afternoon, and welcome to today's NICR webcast series. And hello, and welcome to those who may be watching on the recording. Our title of today's presentation is called Carpool-based Parking Assignment Policy. And our presenter today is Mr. Daniel Rodriguez Ramon. He is a professor of civil engineering at the University of Puerto Rico, uh, Mayagüez. Uh, he is currently, his research focuses on transportation network design problems and travel demand management. He is currently working on projects related to parking management strategies, transit network design, and humanitarian logistics. He has previously worked on the design of road pricing schemes, the analysis of travel patterns and accessibility of microservices and freight travel demand forecasting, among other subjects. So, with that, it is my pleasure to introduce Daniel. So, Daniel, go ahead and take it away.
Thank you for the introduction, and hello everyone. Today we will be talking about a policy to manage parking demand in conjunction with the use of carpooling. This work is the result of the collaboration of two teams, one in the University of South Florida, USF, and the other team in the University of Puerto Rico at Mayagüez, UPRM. And we organize our work in three trusts, three areas. One of the groups work on the optimization component of our project. Another group work on the prototype development. And lastly, the group at USF, in collaboration with myself and Dr. Alberto Figueroa, we examine the policy implications of this idea that we're presenting today. First, I will present the research objectives, the motivation of our work. We will try to connect our work with previous research. Then I will present the model and the heuristics developed to implement our ideas. After that, I will show you some results from a survey that explored the policy preferences of the people that participated in this survey. Then I will present a prototype, or the idea of the prototype that we're trying to implement at the University of Puerto Rico, Mayagüez, UPRM. And I will end by mentioning some future research directions. The objective of our project was to develop an equitable strategy to mitigate parking scarcity and mobility problems. And as you probably deduce, we organized our work around 3 points. We wanted to develop the mathematical models to implement the strategy. We analyze public perception of this strategy, and then we are trying to test the strategy in the real world through a prototype. This project was motivated by a perennial problem at the University of Puerto Rico, Mayagüez. Since the 80s, I think, we have had the problem that there is simply not enough parking for all the people that want to reach our university. And that's because Puerto Rico and our university is auto-dependent. We really have very limited public transportation options. So people depend on their own private vehicles to reach the university. And this results in a plethora of problems. Obviously, people waste their time looking for an open space, but it also motivates informal or illegal parking behaviors that create, in turn, safety problems around the university. This situation is obviously not unique. The extent of it is open to debate, but we know that a non-trivial proportion of urban traffic can be explained by people searching for parking. And this results in an inefficient use of resources that have a high cost in terms of the economy, environmental, and public health. You could say even emotional health, due to the stress that searching for an open parking space creates. So what can we do in this type of situation to address these problems? There are several types of options that are available for planners and decision makers, but we are focusing on the strategy of managing the demand, the travel demand. The management of demand has as its ultimate objective to reduce or shift the demand for parking, if we are thinking about demand for parking specifically. And we can think that some strategies are of the type that they are voluntary, and among these are carpool incentives or incentive for carless travel. And at the other extreme, there are mandatory strategies or control strategies that use parking pricing or some other obligatory parking allocation approach. Another alternative is to shift activity. For example, in the context of universities, you could shift class schedules, and by doing so, you reduce the travel peak. Parking pricing is the standard or the orthodox strategy, one of the most supported strategies to address the problem of excessive parking demand. And in this area, Donald Shoup has contributed many papers and publications that have argued in this direction. And as a result, there have been major parking pricing projects that have successfully launched in recent years and have demonstrated that indeed parking pricing is a strategy to reduce the problems caused by cruising for parking. There are some challenges though with parking pricing. The two major ones are political opposition, which is often connected to equity concerns. Obviously, these problems are not unsurmountable, and there and you could say that parking pricing might be regressive, but there are other financing alternatives that are also more regressive, perhaps could be more regressive than parking pricing. But in some contexts, parking pricing is a hard sell, and this type of context could be described as follows. For example, in our university, we have limited public transportation options, and it's unlikely that the government would step up to solve that problem. We have a high proportion of low-income community members, students. We have a low population density, and there are students that travel from far away because they cannot rent housing nearby. And we have a high concentration of activities at a single point, in this case, university. So in a place like this, where there are little options besides private vehicles, parking pricing can be very problematic. I mean, it's, in our context at the University of Puerto Rico, it would be a non-starter. Uh, there's no way that that could happen at the moment. No pricing, so we are proposing a no pricing carpool-based parking assignment policy approach in which the carpools serve as a substitute for parking pricing, and a centralized system decides who gets to park in the university or any other venue that shares these characteristics. Before I give you the details of our idea, let me talk about some related work that is relevant. As I mentioned, we are proposing what we believe to be a new travel demand management strategy. And the model that we are presenting to implement this type of strategy can be considered an extension to static ride matching problems that assume flexible customer roles, drivers or riders, multiple rider pickups, and guaranteed ride back. That means that when we are model, when it's deciding on who gets to join a carpool, the people that are riders in the carpool will have a vehicle that will take them to the venue and from the venue back to whatever place they want to be. So there is a guaranteed ride back. Previous peer-to-peer ride matching work has considered transit service transfers, pricing schemes, and the use of HOV lanes, and rider transfers between drivers, among many other issues. We believe that, at least to our knowledge, our model is the first to account for parking considerations. In terms of non-pricing parking management strategies, this can be broadly categorized into two: static systems with cyclical allocation of parking slots, and dynamic systems for real-time parking slot allocation. And in this area, I think one of the first papers that has considered this type of problem was the paper by Goyal and Gomez in the 80s. They proposed a linear programming model that allocates permits among different individuals in the context of universities. And their goal, the objective of their model, was to minimize total walking distance from parking lots to final destinations. Beyond non-pricing parking management, there are very interesting travel demand strategies that also avoid the use of pricing. For example, researchers have proposed highway access booking system. This is a reservation system to enter highways, downtown space reservation systems, and there is very extensive literature on tradable permits for road access. And this paper here by Fan and Jiang represents a review of the many papers in this area. So we are contributing to this area of research of non-pricing travel demand management in the context of parking. So now let's talk in detail about our idea. We're proposing a centralized system to allocate parking and coordinate carpools that we're calling, at least for the purpose of our publications, parking allocation and ride-sharing system. The basic idea is that at some period t, you could say, some period, there is a group of passengers, and then there is a group of drivers, and these people have desires to make a trip to a university, for example, just to give some grounding to the conversation. The passengers are assumed to submit to our system, the PAR system, trip requests, and the drivers submit parking requests. And all of these requests have information, for example, regarding the desired arrival times and the desired departure times from the venue. In terms of in the case of the drivers also specify the capacity of their vehicles. Then this information is submitted to the system, and the system, through an optimization model, determines the optimal selection of drivers and carpools, and also determines the parking reservations that are accepted. So in this scenario, you could end up with situations in which carpools, for example, carpool one, are composed of a driver and a person that wanted to be a driver plus a person that identified as a passenger. And then carpool two is composed of a person that wanted to be a driver and then two other individuals that wanted to be riders. So the idea is that in this system, ideally, this is a conceptual, at this point, it's a conceptual model. You will control all parking spaces at the venue using the parking allocation and ride-sharing system. This is presented as an alternative to the pricing strategy. And then this process of submitting requests will cyclically repeat itself um, for the time necessary. For example, if it's a university, then this is just an example. In a semester, you could have weekly processes in which people submit trip requests, parking requests, and then the system makes a determination for each day of the week which parking reservations, parking requests are accepted, and what carpools will be using those parking reservations. So the idea, as I mentioned, is that we are assuming there is a single parking location. There are many people that want to reach that parking location. We determine which carpools and which parking requests are accepted using a mathematical optimization problem that wants to attempts to maximize social objectives subject to a set of constraints, the most important ones being the parking capacity constraint, constraints related to the to user schedules. For example, if people need to be at the university at a certain time, then they need to reach university before that time. So we don't want people to arrive late, obviously, to their desired location. Also, vehicle capacity constraints. So a driver will transport more than one person. And we want to ensure that the model doesn't assign more people that the vehicle can carry. Uh, Ultimately, we propose a linear integer programming problem that wants to minimize generalized cost. If you want to see more details about this model, you can search this paper that we published recently. If you don't have access to it, then you can email me and I can share a copy with you. To solve this problem, we developed two heuristics. The right decomposition heuristic is a decomposition-based heuristic that first solves a subproblem associated with the problem of going to the venue, and then given that solution, it solves the subproblem associated with returning from the venue. And in addition, we propose the quick converge heuristic, which finds the minimum cost solution and manipulates those solutions considering parking capacity restrictions. And numerical tests were conducted with both heuristics, and it was found in the test that we conducted. So in this test, we evaluated the number of parking spaces, the ratio of drivers to riders, the ratio of drivers to parking spaces. And on average, the heuristics, the right decomposition and quick converge heuristics solve the problem 42 and 86% faster, respectively, relative to a commercial solver. And it found solutions that were around 3% off from the optimum. Now let's talk about a study that we conducted to explore people's preferences regarding parking policy. We surveyed people at the University of Puerto Rico and at USF. 456 people participated from UPRM and 261 participated at USF. We wanted to explore the factors that influence people's preferences for our system, PARS, versus parking pricing. Primarily, that was the primary goal, although other things were explored. And we also explored people's stated comfort with giving a ride to or traveling with strangers, which we believe is one of the main, or we hypothesize that it was one of the main obstacles to accepting this type of strategy. To give you some context of the two universities, UPRM has a permit-based system that is distributed based on community member classifications and is distributed free from out-of-pocket costs. In other words, nobody pays for their parking permit. It's just based on community member classification. For example, students that are in third year, they can park at a parking lot that is closer to the instruction buildings, whereas first year students, they don't really have a permit. In case of USF, community members must purchase parking. In addition to demographic questions, we created stated preference scenarios questions that presented people with choices, hypothetical choices, naturally. For example, in stated preference questions for parking present people with two choices. They could either drive alone and pay for parking, or they could be drivers in a carpooling arrangement, provide transportation to some riders, and have guaranteed parking. And then each question varied the attribute levels. We considered, in the case of the parking choices, three attributes: parking costs, number of passengers, and added carpooling time. And we also had another set of questions related to more choice in the case of people when they were riders in a carpool. So we presented both situations: you as a driver or you as a passenger. And this data was analyzed using discrete choice analysis. Multinomial logic models were estimated. And I will just show you some of the results for the parking choice model. To our surprise, given some initial conversations that we had, some pilot conversations, or focus group conversations, you could say, it was found that females were more open to the idea of choosing the carpool option. And the USF community members were the least likely, or less likely, I should say, less likely than UPRM community members or participants to select the carpooling option. Let me repeat that just to emphasize. So the USF members were less likely relative to UPRM members, participants, to select carpooling. This may be related to the fact that USF, there are differences besides the policy. USF already uses pricing, and perhaps, although we didn't really have data to specify this or to test this, but an idea could be that there are certainly differences in the income levels. Puerto Rico, in general, has substantially lower income than the population at Florida, the USF. So UPRM participants are less willing to pay for parking because they have less income, and they're not used to or to this type of parking arrangement. Naturally, the parking cost was significant. As the parking cost increases, so does the likelihood that somebody selects the choice of carpooling. And also, as expected, increasing the number of passengers decreases the probability, and so does increase in travel time. These are expected results, but what they reveal to us is that there are some conditions, some ranges in which, or situations, scenarios in which people are more willing to to have a preference for a parse type of strategy versus a pricing strategy. And if you want more details about this survey and its results, you can email me later, and I will share the paper that has these results. This was done in collaboration with the USF team. It will be presented at TRB next year. Something that we also found interesting is the comfort level that people have with the idea of carpooling. And when people were answering the following questions, they were assuming that we're talking about a university coordinated carpooling program where the identity of people can be determined with certainty. That's the mindset that, or the prompt that was given to people when they were asked, for example, to express their feelings regarding the following statement: I would be comfortable with giving a ride to a fellow student as part of a university coordinated carpooling program. As we can see, only around one-fourth of participants disagree with this statement. So there is certainly an openness to the idea of participating in a carpooling program. And this openness was observed uh, in all genders that participated in this survey. And then to the statement, I will be comfortable with being a passenger in a university coordinated carpool, we see that in this case, still the majority would be open to this, to being a passenger, but certainly more people disagree. Above 30% disagree with the idea of being passengers. Oh, I should mention that these results that I'm presenting now are only for the UPRM community of participants in this survey. Now let me talk to you about the prototype that we're working on. Our goal is to create a system that implements the strategy that we have developed and that can solve some problems here at the University of Puerto Rico, Maya West. And for this, we have created the reservation optimized carpool system, ROCS. That's the acronym. The goal was to create an attractive acronym. And we have, in collaboration with the university, identified a small section of the student parking lot that has a single point of entry and exit, so it's easy to control the flow. And in this small section of the parking lot, there are around, if I recall correctly, 30 parking spaces, 20 to 30 parking spaces. And it's here that we hope to launch our system. The prototype is composed of two main components. First, there is some hardware that has to be installed. The entrance to the parking section that I'm presenting here will be controlled using parking arms or parking mechanical arms. And then people will submit the parking and transportation requests using the ROCS Carpool application, mobile application. We're currently working on various types of app notifications to launch the application. I mean, the application already is available in Apple Store. It's also available in Google Play. I don't think you could download it, but I don't think that you could use it because you will have access only if you have an email from the University of Puerto Rico. So it's I don't advise it's not useful to download it. You can download it if you want, but I don't think you can do much with it. And the idea is that the Carpool app, Trucks Carpool app, will allow people to submit the request. Then, after a short period of time, the the software, I should say, the model that is implemented using different optimization tools that we are using, will select the reservations that are optimal given our objectives, and also will notify people of the carpools that have been formed. So everything will be done by the optimization model. And then this information will be communicated to the participants using the application. And then once people arrive to this location, they will also use the app to certify that all carpool participants are inside a vehicle. And once that is done, using geolocation, then the parking arm will open and give access to people, to the vehicle, I should say, to the vehicle, and then they can park people in the carpool. That's our goal. That's our hope. That's what we're aiming at. We are hoping that we can launch this system by late this month, in a couple of days, or early November 2023. That's our goal. Currently, We are conducting system tests with the parking arm, and we are improving the application. There are some small notifications that the students are working on, another logic that we want to implement. And it's an exciting period for us because we know that there's some known unknowns and unknown unknowns. For example, something that will be interesting to see is with time how people will try to game the system, what strategies we have not thought about, how we need to correct the applications, what happens when um, some people start buying multiple phones. I mean, there's so many things that could happen. So we are excited to see what happens when the system is launched. And we are also planning to conduct surveys to assess user experience with the system that we are proposing. In the future, we want to develop a hybrid pricing parts system. So the idea is that a model, an optimization model, will decide, given a parking venue, what proportion of parking spaces will be assigned to a parking pricing alternative or choice, and then what proportion is allocated to a carpool-based parking assignment strategy, the parts strategy. And you could imagine that there are some benefits of having this hybrid type of system. Obviously, you need money to run this system, so you need to you might want to generate revenue to operate the system. And you also might want to generate revenue to create incentives, monetary incentives that could be used to motivate drivers to pick up people or to just cover the cost of picking up people. I mean, the motivation, the idea of the parts only strategy, if the drivers will be motivated to provide carpooling to people, because once you pick up someone, you have guaranteed parking. That's the idea behind the parts. But if you also add that you could gain some money or at least cover some of your costs, then that could improve overall well-being of the system participants. We're also interested in searching for faster and more optimal heuristics, and we are also working on improving. We hope to improve the ROCs application, especially given once we start seeing the things that break in our test run with the prototype. For this, our students have received funding from Toyota Puerto Rico, and we hope that this funding will extend the duration of this project, at least to cover the cost of the students. This work was supported by the National Institute for Congestion Reduction, funded by the U.S. Department of Transportation Office of the Assistant Secretary of Research, Technology, University Transportation Sectors Program. So now I'm open to your questions.
Great presentation, Daniel. I also say that your references are included as well at the end. If you have any questions for Daniel, it looks like we've got a ton of questions, and they vary. Excuse me, they vary in length. So we'll start at the questions at the top, and then if we don't get to your questions, Daniel, hopefully you'll be able to just respond to some of these participants via email. Would that be a good idea?
Sure. Yeah,
Okay.
yeah, you can email me for sure.
Yeah, perfect. Okay, so let's start with the first question at the top. It says, "How are the parking permits for UPRM and USF enforced?"
I cannot speak for USF. Maybe some USF community member in the call could speak for them. But in the case of UPRM, uh, the students' parking permits are enforced. Their use are enforced through transportation officials. So at the entrances of the parking lots, there are, you could say, guards that verify that the vehicles that is coming through has the Literally, the person has permit, a physical permit that is visible from outside. And if the person has that permit, then they can enter. And there's other parking spots that have, I think, RFID tags. These are for the professors and the staff. And the entrance is controlled through mechanical parking arms.
Okay, I can answer the portion on the USF side. Student parking permits are enforced by uh, the USF Parking Services comes around with vehicles that will scan license plates. Cars must be pulled in, not backed in, with the ability, so they have the ability to scan those permits in us places that have been designated for students, and then lots that are also designated for faculty and staff. I hope that answers the question. Okay, the next question is a bit long, so I think maybe what we'll do is ask this question in parts. It says, "Is the strength of the participation incentive for drivers based on current cost difficulty of finding parking being significantly greater than the expected cost slash difficulty of identifying, collecting, and carpooling with riders?"
Is the strength of participation incentive for driver based on the, yeah, I think that's the idea behind our proposal, that the cost that people incur searching for parking spots in a situation where there's no pricing. So essentially, the situation in many urban areas and at the university, that cost, that this utility, that stress caused by you searching for parking will motivate you to to participate in the carpooling program. But I should mention that the broader idea, or the original idea, the model, yes, the idea presented by the model, is that everyone that will park at the parking lot will be obligated to be part of the park system. So it's not really a choice. It's that's just an, let's say, an idealized situation. In the context of our prototype, which is not everyone, it's just a very small section of the parking lot, then we believe that people will be motivated to participate in our prototype, in our program, because right now it's a pain to find parking spots at the university.
So there, let's follow up with the second part of that question. It says, if so, wouldn't this gap reduce over time if your implementation starts to be successful? And then this person goes on to say, I guess my question relates to whether your goal is to maximize the um, incidence of carpooling, which is more ambitious, or simply dynamically optimize supply slash demand of parking.
I think our goal is to minimize this utility, overall this utility of people that are part of a community, for example, university community. And in doing so, we're using carpooling and the idea of matching people to a reserved parking spot. I think just since I think your question is more relates to our particular implementation, an additional incentive is that, as I mentioned, first year and second year students do not have uh, a permit to park close to their the places of instructions, are buildings, the classroom essentially. So those students will be highly motivated to participate in the carpooling program because they will just have a chance to park in this main student parking lot.
Okay. And this one just wants a little bit of some clarification in terms of uh, the logic model and the p values. And they're just wondering if you could explain the story that p values and other numbers actually mean.
Oh, sure, sure. Oh, well, let's say for a layperson, You could say that, I mean, there is some orthodoxy that there's a lot of debate about the value of this type of things and controversy, you could say. But just to be simple, you could say that as the p-value lowers and close to, let's say, less than zero point zero 0.05, you could say that you have confidence that the estimated value is different from zero, that that is statistically significant, and that is not just something that you can ignore. So in this case, the p-value is very small, so you have confidence, a level of confidence that this estimate that you have here is giving you useful information. Let's say in the case of these other variables that are in the model, they have p-values that are very high. So you can disregard them because you don't know if they are really zero. Maybe they're just zero. You cannot eliminate that possibility. There's no strong statistical evidence that they are useful. And in the case of these variables, we expected them to be uh, important to explain people's behavior, parking costs, number of passengers, the travel time that is out in carpooling. It turns out that, I mean, that our common sense expectation was true. Those factors are important in at the moment when people are answering these stated preference questions, hypothetical situations.
Great. Okay, here's the next question. Has consideration been given to establishing, promoting, and identifying carpool pickup locations at select based based on convergence originate based on convergence or origin points?
That's a very good question. We have not yet thought about this, but I think that once we start gathering data through the test, we start learning and talking with people, we can certainly start to go to this next level, I think, next level thinking of also optimizing the pickup locations and drop-off locations. That is something that I think other transportation services are already doing. For example, microtransit models and applications already optimize this type of issue. So it's certainly something that we can consider. It's a good idea.
Okay. Can you discuss timing a bit more? How much in advance can people request a ride, or how close to time, and how quickly can people are people notified?
This is a good question. We this is a parameter right now. Like, let me give you some story of what we are currently at. Uh, right now, we are thinking of people having more than 24 hours for them to. There's a period of 24 hours where they submit their requests, and then after that, there is another 24 hours in which people are notified of the decision that the system made, and then they can make arrangements. We believe that, so once you get matched with someone, you will have their contact information, and so you can, by yourself, as your little group, your carpool group, can communicate and make arrangements. We hope that the idea that the people will make arrangements, for example, on what would be the pickup location and this sort of issue. This is only for the prototype that I'm talking about. As the models run very quick but quite fast. So it's probably for sure less than 10 minutes, for sure. I mean, less than 1 minute, this will probably solve the problem because we don't expect, I mean, there are less than 10,000 students at our university. Of those, probably half are using cars. Of those, then just a fraction of them will probably be interested in using our system. So we expect the software, the model to be solved very, very quickly. So it's not really an issue of of the model. It's an issue of people having the time to react to the information that is given. And we will certainly learn through the prototype what problems, things that we need to adjust. That's the point of the prototype experiment, of this testing phase, just to clarify this type of issue.
Okay, great. Okay, let's keep going. If you need to take a drink, Daniel, now's the time. Do you think that people tend to be biased to prefer what they currently do versus making a change, even if a change might confer more than a benefit?
I think so. I mean, we didn't, this wasn't something that we directly studied. But from just more general transportation knowledge that we have collected through the years, I believe that there is evidence that people have some inertia with regards to their travel behavior, and there are many unknowns. I keep thinking of our situation. There are many unknowns that might dissuade people from participating in the program. But we, sadly, given our very bad parking situation, we believe that would be a huge motivator for people to participate in our program. Just last week in social media was people, just students sharing their frustration with the amount of time that they have to spend searching for parking. So it's a we expect to be a lot of interest in our program.
Great. It says, can you please describe a typical end to end use case for a student driver who decides to use PARS and carpool to campus? So I'm trying to get a little bit more detail on the exact steps that the student driver will go through from the moment they select or they decide to use PARS to the moment they and their riders park on campus and exit their vehicles.
Yeah, that's makes a lot of sense. So if I'm a driver, the first thing I will do is I will log into the app. Then I will start creating my parking request. I will specify my desired arrival time, my desired departure time, the vehicle that I have, the number of spaces, and the locations that I will be starting my trip. And then I will submit this request, parking request. Obviously, by the fact that I am participating, that I'm submitting this request, I'm aware that I will likely have to transport someone. Then after everyone is done submitting the request, the drivers and the potential passengers, then the parts system will make determination on whose parking requests, driver parking requests are accepted and who are denied their request. And then people will get notifications of the determination of the system, the parts system, and they will also get notification of who are the people that they need to transport in case of the driver. And this information that they will receive will include the phone numbers and emails of the carpool participants. And in theory, I will start chatting with these people just to make sure that we are clear on what the plan is. And then lastly, I will arrive, we will pick up everyone. There's some logic that has been introduced in the app to break. For example, imagine that there is a carpool participant that doesn't show up, it's a no-show. Then there will be a button that will notify the system that this person is not part of the carpool. Next step is that we drive to the parking lot, and using the app, we will we will certify that we are at the parking lot. And the arm, or in front of the parking arm, I should say, then the arm will open, and then I will access the parking lot and park. And in case of the from the university trip, then a similar logic will happen, will occur. I hope that answered the question.
Great. It says, will the carpool driver and passengers combination be the same for the return trip?
No, no, they not necessarily. The answer is no. It's flexible. You could arrive with one driver and then return with another driver, and that is likely because people have different schedules.
Okay. It says a big issue at university is the abuse of carpooling. Participants say they're carpooling when in fact they don't, which your gate geolocation appears to address. Will this part of the solution be available to other universities in the U.S. and abroad? And then they ask about the cost associated with the implementation.
We are at a testing phase, so we have not demonstrated that it works. Our goal is for our goal is for the answer to this question to be yes. The solution will be available to other universities in the US and abroad, and it may have an appropriate cost. I don't have the answer for the cost, but we first have to naturally demonstrate that it works. One of the things that we need to explore is what's the delay, the delay between, say, you are at your parking arm, everyone is sending, in theory, submitting through the app that we are here, and then the parking arm opens up, how much time has passed. And our students are currently saying that it's just fractions of a second, but we really, I mean, we need to see that. And it obviously would depend on the quality of the internet service, data transfer. There are many unknowns that that we need to answer, and we hope to have positive results before the end of 2023.
Okay. It looks like we've got one final question. It says, "How do you ensure that people don't stay too long at UPRM if control is only at entrance?"
Yes, that's a very important question. And for that, we hope that the notifications, we have implemented already a logic to this. We have implemented a logic that people get a notifications 30 minutes before their the time that they need to leave. And as I'm talking about this, I think maybe we should implement an additional reminder 10 minutes before, 30 minutes, 10 minutes before. That should be, I mean, this already has been implemented. We can probably adapt that. And we hope that that will be enough of a procedure, an effective procedure or mechanism to make sure that people leave the parking lot in time. Another thing that we were thinking about is to have some slack. Say we have 30 spaces, but always have two or three spaces always open in case this type of situation happens where we have a vehicle that doesn't leave at the appropriate time. This is something that we will also explore.
Great. Okay. And then, Daniel, we just received a couple comments about the question regarding origin points. It said, "I believe focusing on origin points is critical for long term success, but this will probably only make sense once you have greater participation." And then a follow up comment said, "So common origin points will become a more powerful incentive over time."
Yeah, I agree. I think right now we are approaching this problem from a sort of a low information point. As we have more data, we can probably implement smarter, more coordinated ways of arranging this type of programs.
Okay, great. Well, it looks like we got through all of those questions. Thank you so much to everybody that stayed on during the Q&A portion. I am going to open up the evaluation on your end. Please take a few moments to complete the evaluation, as the feedback is very important to not only Daniel, but the entire NICR webcast series. Again, if you sign up for our upcoming newsletter, the NICR newsletter, you'll be notified of all of our upcoming webinars. So, on behalf of the National Institute for Congestion Reduction, thank you so much for joining us today, and we'll see you all real soon. Bye, everybody. Thank you, Daniel, so much.
Thank you. Bye bye.
Have a great day.